Okay, so we have so far reached the level of implementing spanning tree. So to implement spanning tree in the pack tracer, I will go to the switches down here in the corner, the second icon. I will take two switches first. This is one click, release your mouse, and another click wherever you want. Another switch please, one click, and take your mouse and perform another click in here. How this size is good for you to check. So by default these two switches have their ports all are up and running, we have no problem. Let's just call this one switch 2. Don't get confused with the number 0. This switch will become switch 1. So from connections, from the automatically choose connection type, let's just have one click, move my cursor, and have another click on switch 2. These two are now in the negotiating of learning process. Okay, so it takes about 30 seconds. This is our time, so we have spent so far about an hour, 57 and 45 seconds. Okay, 57 minutes. So it's either I wait for them or I just press fast forwarding. Let me wait for them. Okay, so these two greens port must become, these two amber ports, sorry, must have the green port. Okay, this is what happened in the real life. In the real switch life, I hope I will be able to record and upload a video for real switches in the upcoming week. Okay, what you will face is that all the interfaces will have LEDs. Okay, we'll have small LEDs of two colors, the amber and the green. So this is the same thing, that this is emulating this real thing that you will see in the environment. Okay, you'll have a switch, have 24 ports, all of them has their small mini LEDs, LEDs. Okay, it will become all of them amber at first. After that you will see they blink and become green. Okay, some types will be always blinking green, others will be solid green forever. Okay, so this is what happened first. I have no problem, I have no need for spanning tree, but just because of redundancy or to increase the bandwidth, I have another interface that is connected between them. Now there is negotiation between these two interfaces. We need to wait for about 50 seconds to see the result. So let me press fast forward. One of them become green, the other one still holding. Maybe another fast forward. Now we are about more than 1.5 minutes of waiting, so it seems that this interface will stay on this way forever. Okay, so why this interface, why it's not this one? Let me just hit click CLI. Let's just increase this one. Our first command of spanning tree will be show spanning tree. Okay, at that simplicity. Okay, so for show spanning tree, VLAN 1, by default we are all at the default VLAN. Spanning tree is enabled using protocol IEEE because they invented spanning tree. The root ID, the root bridge ID, is the bridge that has the priority of 32769 and has the MAC address of this thing. This bridge is the root. Okay, that's obvious because my two interfaces are up and running, so I am the root bridge. Okay, this is the timers. This is the maximum age at 20 seconds and the forward delay of 15 seconds. Okay, the bridge ID, okay, has this priority and this MAC address. You can see it's identical. Both of them are identical, means that this bridge ID that I'm using right now is the root bridge. Okay, the same timers. I have two interfaces. Fast Ethernet 01, which is the first one that I have used, is now in the designated, it's a designated port, and it has the status of forwarding. Okay, and the cost of 19, because fast Ethernet interfaces have the cost of 19. The type is point to point because I am connected directly. My second interface is in the designated port. Of course, all of my interfaces, 2 or 40 interface, I don't care, just because I'm the root bridge. This bridge is the root. This means all my interfaces will be designated. All of them will have the forwarding will be in the forwarding state. Okay, so the cost is 19 because this is a fast Ethernet interface. I believe in the gigabit interfaces, we will check if we have gigabit interfaces. This will be 4. This will have the cost of 4, which is lesser than 19. Okay, so this is the first thing. The other thing is that this guy here who sacrificed his interface, it's either that he has a higher MAC address or a higher priority. So enable show spanning tree. Okay, so it has the same priority. No, this is a root. This is the information of this bridge. Okay, it has the same priority, but it has a higher MAC address. Okay, see this seems 0001, but there will become a C which has the value of 12. After this there is a 4 which is a lowest value. Okay, it has 394, but there are 7s. Okay, and this makes this MAC address higher in value than the other one. So this one will be sacrificed, this switch, and the other switch will become the root bridge. Okay, it has 2 ports. The first one is a root port because it is in the opposite of, it's an opposite of the designated one. It's in the forwarding and also have a cost of 19. The second interface, the last one, is in the alternative, has the alternative state, the disabled, the blocked port, and in the status of blocked. So I think I have said that an opposite when I explained it, because I said the status is alternative and the role is block. So I was mistaken. The role is alternative and the status is blocked. Okay, so you might be wondering right now that in the triangle topology of 3 switches, the switch that had maybe the highest MAC address was the one to take sacrifice, which is this switch right here, the same thing. But why fast Ethernet 02 is the one that got disabled? Why it's not fast Ethernet 01? Let me tell you the rule. You are concerned about the interfaces that will stay up and running. Okay, so when you face such scenario or such situation, the interface with the lowest number, the interface that has the lowest number will stay up and running. So I have fast Ethernet 01 and 02. Which one is the lowest? 01. So this will win. This will be the up and running. The other one must sacrifice. Okay, so this is the case. Maybe we will draw another topology. Go back to switches. I have now 3 switches, 1, 2, and 3. Let me do connection between them. This is disabled until it works. This is red. We shouldn't face red. Maybe we have something. Oh, it was a delay. Okay, impact tracer, and this is the final one. All these negotiation and election of spanning tree are happening right now. Maybe a fast forward will make one of them become blocked. The other 5 interfaces are working. Okay, just check what will happen now. Hope it was clear. Okay, this is clear. Okay, redundant connections. Okay, big problem will happen, but spanning tree will fast forward. In the end, this, in each switch we have, this one is disabled, this one is disabled, this one is disabled. So for the first cabling there will be no loop, and between each one of them there is a disabled port. This one will prevent this type of loops, this one will prevent this type of loops, these two will prevent this type of loops. Okay, so I hope this was clear enough for you. Okay, you can now maybe take this one, CLI, and maybe extend it, enable show spanning tree, and you can see how much alternative, only 1 root and 3 alternatives. Okay, but it's clear that this one who has all its interfaces are up and running, okay, is the root bridge. This bridge is the root. All its four interfaces are designated and in the status of forwarding. Okay, so these are some scenarios you might have in the future, what's called the ring topology. This is a ring, and this is also called a ring, but you have maybe 5, 6, or maybe up to 10, 12 devices. All of them are connected together. Some of them maybe will be connected in more than a single connection. What I mean is this. What you will face in the future are tens of scenarios, okay, maybe in this way, this method. What you will see is that this one, the second, the third, fourth, and fifth, this is the ring. After some fast and forwarding, again please, okay, so we have now only single interface is disabled. This is the normal ring topology that you will see. Just also if you work with a service provider environment, okay, or some big enterprise company, this is the topology of the ring. Maybe this link is crossing some hard geographical spot. We have to maybe extend another cable through another geographical area, so we will extend another one, but this will cause some internal loops between these two, so another election will happen, some other disabled interface will happen. So maybe you will find this scenario in the future. Maybe because there is some important customer, we need to extend this cable for redundancy. So now I have split it into two rings. This is a ring, a closed ring, and this one is another closed ring. Okay, so another elections will happen, some other interface will be disabled, some other interface will be designated. Okay, multiple scenarios you will see in the future. Maybe some last thing, I used to work with these topologies before, maybe in this way, just for more redundancy, and yet it was working normally without the need to disable, because it did not cause a loop. Why it did not cause a loop between these three? Because this interface is already disabled. Okay, so there is no loop between these. Okay, so these are a lot of topologies. You can do whatever you like, just connect all the switches that you would like to connect to. After you connect them, oh, maybe let's just take this one. Okay, let me go to my cursor. I believe, how was it to go to this interface? Let's see how spanning tree how much spanning tree does it, or how much spanning tree needs of time to operate. Okay, so I know now that fast ethernet 01 is standby, and maybe yes, fast ethernet 02 which is down. So let me disable fast ethernet 01, configure terminal, interfaces, fast ethernet 01, which is operating. For any reason it got down, shut down. Okay, so the other interface is still, now it entered the maximum aging time. It will take 20 seconds just to know and collect that the other interface is down. So we need to operate. So please, all of you, be ready. I will take you to the next level, which is the listening. After that, the learning. After that, to know which one will be forwarding and which one will be not. In the point-to-point state, where I have a point-to-point, I have a problem that happened between two switches that are connected together. Maximum age will not be required. Okay, so you will not wait for 50 seconds, you will wait only for 30 seconds. Okay, it will be only the delay of the forwarding and the learning. That's it. This is what happens. That's 30 seconds. That wasn't 50 seconds of talking. Okay, so only 30 seconds was enough to decide what, how, or sorry, to decide or to really operate the blocking interface between two switches that are connected directly. But if maybe this root bridge had a problem with this switch, which is not connected directly with it, so at that time it will take really 50 seconds. Okay, it will take 50 seconds, but just for any reason the port was fixed, no shutdown. Why? Oh, I'm sorry, SHU. Okay, shutdown. Now it's up and running. Now again another 30 seconds must happen. Show spanning tree. Okay, both of them are designated, but the LEDs are still not updated. Okay, now it's in the listening. Okay, please, still listening. Again, now it's in the learning state. Maybe it will take now the 15 seconds of the learning delay. The LEDs are still green, amber. Now finally it's in the forwarding state. Okay, so it was disabled, listening, learning, and finally forwarding. This will happen. What happens when you refix your interface? This is all the process of the natural and common known spanning tree. Okay, the SPT, which has the code of 802.802.1d. Okay, just I don't think I have mentioned it, but you must know that spanning tree was invented by IEEE and assigned the code of 902.1d. This is very important for you in the exam. Okay, so 1d is the common spanning tree that we have talked about in the, how much it has been, 3 videos. Okay, so I hope this was informative for you so far. What we'll see in the upcoming video are the upcoming versions and the next versions of spanning tree, because this version takes 50 seconds to operate. If you have important customers, they will not wait for 50 seconds of outage. This is a big mess and a big problem. Okay, so more versions are available. We will talk all about them briefly. It's not really required from you as a CCNA engineer, but we must mention all of them, so you have to know them, and it will aid you in your upcoming studies. Okay, so thank you for watching, and I hope to see you soon. Okay, goodbye.